Yes, it is 270 hertz. Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. In last two sessions, I discussed how we can trace circuit, how we can draw its circuit diagram, and in last video I discussed how we can make a fair copy of this conceptual diagram in Proteus Professional, and today we will place these components on this diagram and we will make connections so that it will give us two different things. First, we will analyze the circuit, different parameters. The second thing, we will take authenticity of this diagram. If you don't have good experience in electronics, never do this experiment because this portion is dealing with live voltage. Take care for the safety. In first step, I will remove diode. Then this capacitor. I will use this resistor, fuse resistor, because its original fuse resistor is burned out. Then this C2 capacitor, R3 resistor, and this diode. This is RCD snubber circuit. It will demagnetize the ferrite core. Then this startup resistor, 470K. It will provide base biasing, that is this one. Then this transistor, D13003, base collector emitter. At emitter there is a resistor, and I will connect directly to the emitter pin. This 1N4148 diode. It is connected to base pin. I will connect directly at base. Then C1 capacitor and 100 ohm resistor at the same pin. And we need to connect this pin with this resistor. Then this capacitor. This capacitor positive side is connected to negative terminal of the main DC capacitor because it will provide negative pull down to this transistor. And we need this diode. Rectifier anode is connected to this capacitor negative terminal. Transformer connection. Transformer, this end is connected directly to the positive. Second pin is drive pin. And here the last pin is ground pin. If you will reverse the connections here, it will not work. Transformer, this end is positive, this pin positive, this pin ground. This end positive. Diode this end negative, this resistor negative, and transformer winding this end negative. And this capacitor positive end will connect it to ground. Now auxiliary winding second end is connected here at this diode. Same point is connected to this resistor, that is this one. Then here is opto-coupler. I will remove it now. One, two, three, four. Now I will place in reverse order. So now this is pin 1, 2, 3, 4. It will become same as in the diagram. Pin 3 of this optocoupler will connect it to negative terminal of this capacitor. Pin number 4 of this optocoupler is connected to base pin. Schottky rectifier 195819. It is reaching to positive terminal of this capacitor. Unluckily, due to over temperature, the camera stopped recording, so this portion of the video is not recorded. This is high side signal. This high side signal is coming to Schottky rectifier 195819, positive terminal of the capacitor, then Zener cathode. Anode is connected to 1K resistor. This node, this center joint is connected to base, and it is also coming to pin number 1. Pin 2 of the optocoupler is connected to ground side. Ground side is coming to this capacitor. Here is resistor, then LED. 560 ohms resistor. Let's apply power. Now we will see its response. This all portion is now live. Now I placed all the components on this diagram, and now we will power it on. We need special care. When power is applied, we will not touch any component. If you want to use oscilloscope, 2-pin power lead must be used without ground. For oscilloscope, or use isolation transformer. Never touch any metallic part for the oscilloscope, and remove all unused test leads. .9 volts. Now we have 4.9 volt output on this capacitor, 335 volt. At input I have 235 volt. DC voltage, this capacitor 4.9 volt, that are coming from auxiliary winding. Always remove power lead before connecting oscilloscope. I will check signal on the base. 1x attenuation. These pulses are on the base. Yes, it is 270 hertz. Yes, 269, 270 hertz. So we can say our this drawing is now perfect. In upcoming session, I will disassemble its transformer and I will share the transformer details. If you enjoyed this video, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.